Hey everyone, and welcome! If you're just starting your journey with Python, you've come to the right place. Today, we're tackling one of the most fundamental building blocks of programming, strings. So, what exactly is a string? Simply put, a string is a sequence of characters. It's how you represent plain text in your code. Anything you can type on your keyboard, letters, numbers, symbols, or even spaces can be part of a string. In Python, you tell the computer that you're creating a string by wrapping your text in quotes. Creating a string is super easy. You just assign your text to a variable. Python is flexible and lets you use single quotes or double quotes. For example, let's create a string for a greeting. As you can see when we run this, both variables hold the string and print out the text just fine. There's no difference in how they work.
You might be wondering, why have both single and double quotes if they do the same thing? Great question. It's all about convenience. It helps you easily include a quote inside a string without Python getting confused. The rule is simple. If your string contains an apostrophe, which is a single quote, you should wrap the whole string in double quotes. Now, what if you want to include double quotes for a quotation? You guessed it. Just wrap the entire string in single quotes. And what if you need to write a string that spans multiple lines? For that, we use triple quotes, either single triple quotes or double triple quotes. Super useful for writing long blocks of text. The most important rule in this entire video is this. Anything you put inside quotes becomes a string. Python doesn't care what the characters are, it just sees the quotes and treats everything inside as simple text. Let's break down exactly what anything means with clear examples. First, the most common use. Regular words and sentences. This is what we usually think of when we hear text. No surprises here. Python stores and prints it exactly as you'd expect. Now, for the most common point of confusion. You can put numbers in a string, but they are treated as text, not as mathematical values. To Python, the string 2025 is just a sequence of 4 characters, 2, 0, 2, and 5. It has no numeric value. The variable year as number is an actual number you can do math with. If we try to add 1 to both, you'll see the difference instantly. The first one correctly prints 2026. The second one gives a type error because you can't do math with text. It's a critical difference to remember. Your strings are not limited to letters and numbers. Any symbol on your keyboard can be included. This is great for things like passwords or formatting. This is where strings get really powerful. Thanks to a standard called Unicode,
Python strings can handle characters from virtually every language in the world, including emojis.
Think of a Python string as a train, where each character is a passenger car. Every car has a unique number so you can find it. This number is its index. Python uses two numbering systems for this train, and you can use whichever is more convenient. Let's use the string Python for our examples. Positive indexing, from the front. This is the standard way of counting. It starts from 0 for the first character and goes up. The first car, or P, is at index 0. The second car, or Y, is at index 1, and so on. To access a character, you use its index in square brackets. Negative indexing, from the back, is a convenient shortcut for accessing characters from the end of the string without having to count from the front. The last car, or N, is at index -1. The second to last car, or O, is at index -2, and so on. This is very useful for getting the last character of any string, no matter how long it is. Both systems point to the same characters. For example, my string of 1 and my string of -5 both give you the character Y.
Slicing is the method of extracting a portion, or substring, from a string. Think of it like highlighting a specific part of a sentence. The main syntax is string, square bracket, start, colon, stop, colon, step, square bracket. The start and stop parameters. This is the most common form of slicing, where you define a start and endpoint. Start, the index where the slice begins. This character is included. Stop, the index where the slice ends. This character is not included. This is the most important rule to remember. The slice goes up to, but not including, the stop index. Let's break it down using this example. Message equals hello world. Extracting hello. The word hello starts at index 0
and ends at index 4. To include the last character O at index 4, we must specify the stop position as 5. This command reads, start at index 0 and grab every character up to, but not including, index 5. Extracting world. The word world starts at index 7 and ends at index 11. To capture the final D at index 11, our stop position must be 12.
You don't always have to provide both start and stop. Omitting start, if you leave out the start index, the slice automatically begins from the very start of the string, index 0. Omitting stop, if you leave out the stop index, the slice automatically goes all the way to the very end of the string. The step parameter. The optional step parameter controls the interval or jump size between characters in the slice. The default is 1, meaning every character is taken. Example, get every second character. To get every other character from Hello World, we can set the step to 2. This starts at index 0, H, skips 1, takes 2, L, skips 3, takes 4, O, and so on. Reversing a string with step. A negative step moves backward through the string. A step of -1 is famously used to reverse a string. By leaving start and empty and setting step to -1, you were telling Python, start from the end, go to the beginning, and move one character backward at a time. Now for the final key concept. Strings are immutable. Immutable is just a fancy word that means unchangeable. Once you create a string, you cannot change any character within it. Let's try to change the string Pam to Sam. We can access the first character with index 0. When I run this, boom, we get that type error again. Python is telling us you are not allowed to change a part of the string. So how do you change it? You don't. You create a new one. See, we didn't change the original Pam string, we created an entirely new string, Sam, and made the name variable point to it. That's what immutability means.
In Python, the backslash is known as the escape character. Its purpose is to act as a special signal to the Python interpreter. When Python sees a backslash, it knows that the very next character has a special meaning and should not be interpreted in its usual way. It allows you to escape from the normal rules of string characters. The most common reason to use an escape character is to resolve ambiguity. Imagine you want to create a string that contains a single quote, but you are also using single quotes to define the string itself. Python sees the first quote and starts the string. When it encounters the second quote in "It's a beautiful day," it thinks the string has ended. The rest of the line, "a beautiful day," becomes a syntax error because it's unexpected. To solve this, you place the escape character, backslash, right before the character that's causing the problem. This tells Python, hey, treat this next character as a literal part of the string, not as a special instruction. By using backslash quote, you've escaped the single quote, stripping it of its special end of string meaning and making it just another character. The same logic applies to double quotes. In Python, an escape sequence is a combination of characters, starting with a backslash, that represents a special, non-printable, or hard-to-type character within a string. Think of the backslash as a signal that tells Python the next character has a special meaning. Here are the most common escape sequences. The new line sequence is the most common and useful escape character. It represents a line break, exactly like pressing the Enter key. Use it to split a single string across multiple lines for cleaner output. The tab sequence inserts a horizontal tab space. This is incredibly useful for aligning text into simple columns without complex formatting. Use it to create neatly formatted column-like text. Since the backslash itself is used to start an escape sequence, how do you include a literal backslash in your string? You escape it with another backslash. Use it to represent a single, literal backslash character, which is essential for things like Windows file paths. As we've seen, normal strings use the backslash to create special escape sequences. This can become messy, especially with Windows file paths or regular expressions, leading to a backslash plague. Notice how every single backslash has to be doubled, backslash, to be treated as a literal character. The solution? Using a raw string. A raw string simplifies this by turning off the magic of the escape character. Whatever you type inside is exactly what's stored. Both of these examples produce the exact same output, but the raw string version is much easier to read and write. Raw strings are most useful in two common scenarios. One, file paths, especially on Windows where the backslash is the directory separator. Two, regular expressions. Regular expression patterns use the backslash extensively for their own special sequences, like \d for a digit or \w for a word character. Using a raw string prevents Python from interfering with the pattern. An important limitation. A raw string cannot end with a single backslash. This is because the parser can't tell if that final backslash is supposed to escape the closing quote. If you need a string to end with a backslash, you must create it using a normal string or by adding the backslash separately.
Python strings come with a rich set of built-in methods, which are like special actions or tools you can use to manipulate and inspect your string data. A crucial thing to remember is that strings in Python are immutable. This means that string methods do not change the original string. Instead, they return a new, modified string. Changing case. These methods return a new, modified string with a different capitalization. The original string remains unchanged. Dot upper. This method returns a new string where every letter has been converted to its uppercase equivalent. Any characters that are not letters, like numbers, symbols, or spaces, are completely unaffected. What it's for? Creating a normalized version of a string for case-insensitive comparisons. For example, if you want to check if a user's input is yes, you can convert their input to uppercase and check if it equals yes. Dot lower. This is the opposite of dot upper. It returns a new string where every letter has been converted to its lowercase equivalent. Non-letter characters are unaffected. What it's for? Similar to dot upper, it's used for standardizing text. It's common practice to store data like usernames or email addresses in a consistent lowercase format to prevent duplicates. Dot capitalize. This method returns a new string where only the very first character is capitalized and all other letters in the string are converted to lowercase. Notice how it correctly capitalizes the first letter, but also lowers the rest of the letters. Finding and replacing. These methods allow you to locate substrings or replace parts of a string. Find substring. This method searches the string for a specified substring and returns the integer index of the first character of the first match. If the substring cannot be found, it safely returns -1. What it's for? Checking if a piece of text exists within a string and finding its location. Because it returns -1 instead of causing an error, it's very safe to use in if statements. Replace old, new. This method returns a new string where all occurrences of the old substring have been replaced by the new substring. What it's for? Cleaning or modifying data. For example, removing unwanted characters or standardizing formatting. Trimming and splitting. These methods are for cleaning up white space and breaking strings into smaller parts. Strip. This method returns a new string with all leading at the beginning and trailing at the end white space characters removed. This includes spaces, tabs, /t, and new lines, /n. What it's for? Cleaning user input. People often accidentally add extra spaces before or after typing in a form field. Split, separator. This is a very powerful method that breaks a string into pieces at a specified separator and returns those pieces as a list of strings. If no separator is given, it splits the string by any sequence of whitespace. What it's for? Parsing structured data. It's essential for reading data from files like CSVs or comma-separated values, or breaking a sentence into individual words.
Checking string content validation. These methods inspect the string and return a Boolean, true or false. They are perfect for validating data. Dot starts with substring and dot ends with substring. These check if a string begins or ends with a specific substring, respectively. What they're for: checking for specific prefixes or suffixes. Common uses include verifying URL schemes like HTTP, HTTPS, or checking file extensions like .txt or .pdf. Returns a Boolean, true or false. .digit. This method returns true only if all characters in the string are digits, 0 to 9. If there are any other characters, letters, symbols, spaces, or even a minus sign or decimal point, it will return false. What it's for: validating that user input is a valid positive integer, like an age or a zip code. .alpha. This method returns true only if all characters in the string are letters from the alphabet. If there are any other characters, numbers, symbols, or spaces, it will return false. What it's for: simple validation of inputs that should only contain letters, like a first name. The len function is one of Python's most useful built-in functions. It is used to get the length of an object, which for a string means counting the total number of characters it contains. Unlike the methods we've discussed, like .upper or .strip, len is a general function, not a string-specific method. This is why you write len of my string instead of my string.len. Len counts every character inside the string, including letters, numbers, spaces, punctuation, and symbols. It returns a single integer representing the total count. Important points to remember: empty string, the length of an empty string is 0, escape sequences, special escape sequences like \n for new line or \t for tab count as a single character. And that's a wrap on Python string basics. We've covered a lot, from what a string is, to slicing it up, to using powerful built-in methods to change it. The best way to learn is by doing. So open up your code editor, create some of your own strings, and just experiment. See what happens. You can't break anything. If this video helped you, please hit that like button, subscribe for more beginner-friendly Python content, and if you have any questions at all, ask them in the comments below. I'll do my best to help you out. Thanks for watching, and happy coding!